Assalamu alaikum everyone. This is the last video lecture of file input, output and management, and today we are going to see random access methods. That means how to access files at specific locations of the file. Okay, so we have learned command prompt usage, then streams and devices, character stream, then we learned how to use binary stream, and next we're going to learn file access or random file access. Okay, so the previous functions are used to read or write files from the beginning to the end, but now we're going to see something different. So instead of starting from the beginning of the file then going to the end sequentially, we can use file access to access any specific part of the file without going through the other things. For example, we are going to learn one function which is called fseek, or it does is seeking. So if you have already learned this, seeking means in a CD, if you want, or a hard disk, if you want to find a specific location or data in a specific location, you have to find it through an action called seeking. So the same thing is used here, or the same name is used here. So this fseek function has three input parameters. One is the file pointer itself, so this indicates in which file I am going to seek, or in which file pointer, and this is the offset. Offset means the amount of data that you have to skip when you are starting from somewhere. For example, if you start from the beginning and if you want to give an offset of 10, that means you want to go to the 10th byte in the file. And if you want to start from the end, and let's say the total number of data is 100 bytes, and you want to offset 10, that means from the end you have to go to the 90 byte of the entire file. Okay, so this is how you can use offset. And the last parameter is origin, which indicates where do we start from the beginning or from the end of the file, or any specific position. Okay, so this function changes the current position of the file pointer. So if you can remember, the file pointer contains three information, one of which was the current position of the file. That means where the file current position of the file pointer is pointing to, okay, in the file. So the offset determines the number of bytes from the origin to make the current position, and the origin can be of three types. One is seek set, the other is seek current, and the other one is seek end. So seek set means to set the current position to the very beginning of the file. Seek end means the end of the file, and seek current means to keep the seeking at the current position of the given file pointer. Okay, all of these three macros are defined in the standard input output header file or library. Okay, so this function returns a non-zero value when not successful, and returns a zero value, returns zero value when successful. Okay, so the next function is ftell. Okay, so this function returns the current position of the file pointer. Okay, and as you can see, the current position is represented as a long integer because the return type of the ftell function is long. Okay, so long integer or integer is same for you and me, but there might be some exceptions, because the integer is of 4 bytes and the long integer is also of 4 bytes. Okay, so this function returns the current position if it is successful, and returns -1 if not successful. Okay, so the examples for these functions are given in page number 287 of the same book, and there are also other different file system functions. For example, the rename function can rename a file from one name to another. Here the input parameter old name is the previous name, and input parameter new name is the new name. Okay, and remove can actually remove the file entirely. Rewind can go back to a previous condition of the file, and flush can actually clear the buffer. Okay, so these are different functions, and we're going to see some examples now. So here you can see this function, program called random access contains a few lines. The first two lines are the two library functions, and the main function has two input parameters. One is the argument count and the other is the arguments. Okay, so this is the location, that means the current file position or the position of the file that will be storing, and this is the file pointer. Okay, so first of all we have to check whether the input arguments are correctly given or not. So we need two input arguments. The first one is the name of the program and the second one is the name of the file, and if two arguments are not given, then we have to print that the file name is missing. You have to give the file name. Okay, and otherwise we are going to continue. So here in this line we see that we're opening the file and we're using the very second input parameter, which is the file name, to open the file, and we're opening it in binary mode. Okay, so we are reading in binary mode, and then we're doing some error checking. Then afterwards we are printing this line, enter byte to seek to. So then we have to give the number of bytes that we want to seek to, or we want to set the current position to. Okay, and that is this one, this location. Okay, so if seek if we are able to seek correctly, then we will continue, otherwise we will say that there is a seek error. Now as you can see, this is the file pointer, this is the number of bytes, that is the offset if you can remember, and this is the seek set, that means we are going to start from the very beginning. Okay, and then we are going to print the value at that position. Okay, using getCFP, using the file pointer. Okay, so for this actually we need a text file, right? So let's open a text file. If you remember from the last video lecture, we had a text file called trying test, right? So we're going to edit this one. Okay, so let's write a few more text here so that it can be read properly. This is test text file, check the position value of this specific character. Okay, so this is the text that we have in test.txt. okay, so now we are going to have to run this program. So we're going to use command prompt again. So let's call command prompt cmd. So we need to go to the specific location, at first the drive, then cd, that means change directory, then copy the address. Okay, now what we need is we need to run which function, this one, right, this file. So we're going to give the command gcc, then random access dot c, then we are going to give it the new name, which is the same as the function itself, as the program itself. Okay, I'm going to decrease the size here. Okay, so random access. Okay, so it has been compiled without any errors. So let's call the program random access, and we have to give the file name also. So what is the file name? The file name in this case is test.txt. okay, so it's asking about the byte to seek. Okay, so let's do some calculation here. Okay, so this is the first byte, second byte, third byte, fourth byte, right? So we want to access, let's say this one, I. Okay, so we need 0 1 2 3 4 5, so we need 5. Let's see whether 5 works or not. So it's giving us the value 105, which is correct, right? So as you can understand, the indexing starts with 0. So if you want to see T, the capital T, then you have to write enter byte to seek 0. So now we're getting 84, which is the ASCII character code for T. And if you want space should be 32, right? And the position of space is 0 1 2 3 4. So if you want to seek to position number 4, we'll get 32. So as you can see, it is seeking properly, it is going to the exact location that I want to go and showing me what is there in that position. Okay, so let's go back to the slide. So after this, next we're going to learn standard streams. Okay, but before we go to standard streams, let's see another example, which is the Rif Copy. This is actually a program which copies one file to another, but in a reverse way. Okay, so here we will need again input arguments, but instead of 2 input arguments, we need 3 input arguments. One is the name of the program itself, the second one is the source file, and the third one is the destination file. So it will copy all the text from the source file in a reverse fashion in the destination file. Okay, so we need to check whether there are 3 input arguments or not, and if there are less or more than 3 input arguments, then we have to print this. This is the usage. Okay, so we're going to open the second input argument file name for, so in this case, which is source, in read binary mode, and if we cannot open it, then we'll print this message, and we're then again opening the destination file. If you cannot open it, then we're giving this message. Okay, so we are starting with the very end of the file. As you can see, this in is the name of the input file. Okay, input file pointer. So this is in and this is out. These are my source and destinations. So here what we are doing, we are starting at the very end, because this seek end means at the end of the file, and this 0L means we will have no offset. So we'll just start at the end, and then we are going to save the location in LOC using ftell in. Okay, because ftell tells us the location, right? So then what are we going to do? We are going to go 1 space back, because at the end of the file there is an end of file mark. Okay, so we'll go 1 space back, and then until my location is greater than or equal to 0L, I'll keep on continuing. So what does this mean? The location position is now actually at the very end, so it has the maximum value. When the location position reaches the very beginning, it will have the value 0. So until we reach that 0 value, we will continue with this while loop. Okay, so inside the while loop, the very first statement is seeking again. So we are seeking this location, and then from the very beginning now. Remember, this is from the end and this is from the beginning. Okay, so we are starting from 0. Okay, so from 0 position. So we are storing that character in ch. Ch is our character variable, and after storing, we are again printing it in the output file, and then we are decrementing the location value. Okay, so each time, for example, let's say we have 90 characters, then what will happen? The location will be 90 minus 1, which is 89. So it will start with 89. It will seek in that position. It will get that value, then print it or store it inside the file, then do a decrement of location value. So the location value will now be 88, then the whole thing will be carried on again, then 87, and like this it will continue up to 0. So everything will be printed in the file in a reversed fashion. Okay, so let's use this program. So the name of this program is Rif Copy.c. Okay, and we are going to, we need GCC for compilation. Then we are going to give the option and the name as Rif Copy. Okay, so compilation is done. Okay, so now we are going to call this program. Okay, so as you can see, we missed the other 2 arguments, which is why it is showing us the error message. So we're going to use the other 2 names now, but what files are we going to use? So we have the program name Rif Copy, and then if you can remember, we wrote a few things in this text file, right, which is test.txt. So we're going to use this as a second argument, test.txt, and whatever we are going to reverse, we are going to write in another file, and we are going to call it trying.txt. Okay, So if you can remember, we already created trying.txt before, so done, right? But what happened? We didn't see any change, right? So let's go back here. So this is the test text file and this is a trying text file. Okay, so now as you can see, everything is reversed, right? But let's have a comparison. So here you can see T and at the very end T, right? So this is a test text file. This is a test text file. So everything is actually working properly, everything is printed properly, but there's a difference. What is the difference? These new lines are not reflected here. Everything is kept in the same line, right? Now if you go back to the code, why does it happen? Because each time we are using seeking. Okay, so what seek does, it uses location value or the number of bytes that actually is in the file. So when the number of bytes is counted, the new line character, then end of file character, all these characters are excluded, which is why the number of bytes is excluding those special characters. And so when we are using seeking to go to each position, we are actually ignoring the new lines and the null characters and the end of files. Okay, so which is why this will not print the new lines. Okay, so then we are going to standard streams. Okay, so this is the very last topic of file input and output. So standard streams are basically used to interact with the already existing streams. Okay, so these things you don't need to declare std in or std out, they're already there. So what are they? Where are they? Are we actually using them? Yes, whenever we're using printf and scanf, we are actually using std in and std out, which is the standard input and standard output. If you remember, the name of the first header file was standard input and output, right? So using standard input and output, you can actually interact with the console. That means print on the console and also scan from the console. Okay, so what this does is actually redirects the device into the console. Okay, so for this to happen, actually your computer has to, or your PC has to support the redirection facility. That means the redirection of input output. Okay, so using std in and std out, fscanf works just like normal scanf, and fprintf works just like normal printf. Okay, so we'll just see an example of this one. So here this is an example. So as you can see, we are not using gets here. Okay, so this function has a variable str, then a character array, and then an integer I. So we are entering a string and then we're using fgets. Okay, but fgets is used for what? For files, right? So instead of file name, we are giving the std in here. Okay, so this should work just like a gets function. So after that, what are we doing? We are removing any new line, because if you can remember, fgets also stores the new line, but the gets doesn't store it. Okay, so then what are we doing? We are just printing this string. Okay, so let's see whether it works or not. So at first we have to compile it, gcc std -o std, oh sorry, std.c, it should be .c. So it was properly compiled. Then std, there is no input parameter, so it's asking to enter a string. Let's say I'm just giving my name, so it's printing it. Okay, so I guess it's working properly. So this actually concludes our file input output class. So these two, there's another one, standard error, but you can look it up yourself. We mainly use these two things. Okay, so if you have any questions, please ask away, because without questions I will not understand whether you understand or not, and you have to ask questions. Okay, so how you are going to ask questions? One is you can give a comment in the YouTube video, because you have access to my video links, so you can comment there. Another way is you can comment in the Google Classroom, and the other way is you can give me a private message through Kubel. Okay, So some people have already given me some messages, so I didn't answer them because I haven't uploaded the videos yet, but now as I have uploaded them, see whether you still have those questions or not and ask me again. If you have questions now again, then I will answer them. Okay, so please ask me questions. Without asking questions, you will not understand whether you have problems or not, and I will not understand whether you have problems or not, and then we'll all have problems, right? Okay, so I'm going to end it here. Assalamu alaikum warahmatullah.